Hey guys, I'm gonna check out this schematic here I just was playing around with. I got these toroids here that are supposed to be able to hook up 120, or I think they're made like that so you can run 240 to them in Europe and whatnot. It came out of a PA system power amplifier. They're pretty common. Anyway, I got it wired up in series, the two primary coils in series, so it's 240 volt mode, but I'm only putting 120 to it, and I'm running at about 350 milliamps for 12 watts according to the watt meter. The top secondary coil there is supposed to be a 44 volts. It's actually reading about 98 that comes out of it. We've got a 5 microfarad capacitor in series here, and on the other side, instead of another capacitor like we see in traditional hairpin configurations, I've got a high voltage step-up transformer. That's this guy right here. So just the primary coil of that is in series, and on the other side we've got that 5 microfarad cap. Now after that, we've got this guy, which is a 24 volt in one side and on the 240 volt out on the other side. So I'm using it in a 1 to 10 configuration, and that's the one you see right here. So 24 in, 240 out. So that's not actually the actual voltages that we're dealing with here. And then out from that, I'm just rectifying it and going to another 5 cap there, and I'm reading about 500 volts DC out of this. So let me show you this interesting behavior. So it's turned on. The voltmeter shows 540 volts. I'm going to, let me start from the beginning here. I'm going to discharge this cap. Sorry about all the sun, it's brighter than hell today. Alright, so the cap's dead. There's like 700 millivolts on there. No voltage output here from the secondary. I'm going to short this cap. Nothing happens. No voltage being stored there. Okay? Now I'm going to turn it on, and the first thing we see that happens is we get 3.7 volts building up on that output capacitor over here. Meters right across this capacitor after it's rectified from the 240 out. Alright, now I noticed whenever this ringing effect is going on in here, there's a ringing that's being trapped in this side between this toroid and that transformer, and it only works with this 5 microfarad capacitor. Going down to 1 microfarad doesn't work. Going up to 100, anything drastically beyond 5, the effect is not working. So I have to try with some little slightly closer to 5 to see if it's any better or worse too. But I found that by pulsing this coil here, or at least allow it, because it's high voltage, I can allow it to arc, and not a constant arc, but just a single arc, kicks this ringing into action that's going on here. So I'm going to show you now. I'm going to give it one little tap here, just a screwdriver, let it arc, and the voltage instantly climbs to 500 some volts DC because we're rectified. It's maybe about 300 or so AC coming out of here. So if I'm to let that arc continuously, see it arcing there, voltage starts dropping. It doesn't come up anywhere near as much. I can short this out. It goes down. You see we hover around. It builds up slowly, but not like 500 like it was before. It's once I hover around 287. Let me remove that gap, widen it so it's not arcing. You see we get up to 500 again. Now how fast is that, you ask? I can discharge it right away and it's right back. Hold on. So it comes right back really quickly. Now, letting this arcing that anymore doesn't seem to affect it very much. However, if I discharge this reactance capacitor here, this 5, watch what happens. The ringing stops and the voltage starts dropping. And I can discharge this capacitor now. and we're back to our 3 volts. It doesn't come back up. So by discharging that guy, it cancels all the ringing that was going on in there, and it's not pumping any more charge into there beyond the 3 volts that it normally would. And the interesting thing is that there's no voltage potential building up on this capacitor either. So I can arc it multiple times after that point. You see the voltage barely fluctuates, tens of millivolts, until I kickstart the reaction again, and here comes the 500 volts again. And now I got a discharge there, and it slowly decreases. Kickstart it again, back to 500. I can arc it over and over and over and over and over again. It climbs back up to 500. Hold on one sec. Alright. It climbs back up to 500 in no time. Until I arc this capacitor here, the ringing stops. When I arc it, it stops, I should say. Until we kickstart again. Then it starts ringing. So I originally had this little 120 to 30 volt little transformer, step down transformer there, and I was getting about 12 volts out of the secondary on it, and I was noticing by arcing it, by shorting that coil, I was getting, 30, 60, 90 volts building up here beyond that 3 volts. So it was really interesting. This doesn't happen when I swap this out with a capacitor. So if there was just 2 capacitors in series here, I'm not getting any ringing effect at all. And like I said, with any size drastically different than the 5 here, I had a 0.64 microfarad, didn't work. I had a 150 microfarad, didn't work. Just not getting the ringing in there like I am with this 5 here. So something with this configuration is just ideal, it appears, for this ringing effect. Schematic again. Pretty neat, huh? What's going on here?